All right, this is a demonstration for the analog input of M430 microcontroller. And you can see that all these connections are on the back of the board because all these wires are available here and also in your box are male-to-male headers. And you can see that the circuit connection looks like this. So this A0 is a pin, one pin of the microcontroller. And the voltage output of the voltage divider is being connected to A0. So it's going to read all the voltage analog voltage output from this voltage divider. Because both of the two resistors are 10K ohms, and this is a fixed value. This is a potentiometer, and it's adjustable. You can imagine that if I twist the little knob of the potentiometer to here, so for example, this wiper being shorted to here, and A0 is going to read the full VDD range. So which means your ADC is going to read a bandwidth value of 1023 because that's the maximum value for the 10-bit ADC. And if I twisted the wiper to here, okay, so which means a half of the VDD is being sent to A0, right? So you can imagine that the bandwidth reading will be probably 511, 512, but actually in the real world, it won't be that accurate. There will be some residue resistor being shorted to here, so it's going to be something around a little bit higher than 511, okay? And you can see that demonstration if I twist it. So now it's the lowest value, and that's why for this green LED, which is directly connected to this pin of A0, there's no voltage being output to it. If I change it, you can see that it's getting brighter and brighter. It's being turned on. But however, the frequency of the red LED will be lower. So the reason is in the code, I set up the voltage reading directly as a time delay between the on and off of the red LED. So when the voltage reading is larger, which means it takes longer time or longer delay to turn on and off this LED, so the frequency is actually lower. So that's the lowest. It's actually, if it's 511 milliseconds, and for one cycle of on and off, it's going to take 1 second, right? So it's actually 1 hertz. And if I twist the knob to the other direction, I can turn off the green LED, and the frequency of the red LED will be higher. The reason is time delay is shorter, and the frequency will be higher. Okay, hopefully you can repeat this experiment.